large language models, Agentic AI. These breakthroughs are shaping the next step in human intelligence. They will soon transform industries, change every part of our lives, and push the limits of what's possible. Join us. Be at the forefront of AI innovation. Collaborate with industry leaders to shape the future. Together, we'll lead a new era powered by AI.
Good afternoon, everyone. Welcome to the International AI Technology and Product Forum at Apsara Conference. Today, we're here to explore the cutting edge of AI, from infrastructure and models to groundbreaking applications that are shaping our future. To kick off, please welcome Dr. Li Feifei, Senior Vice President of Alibaba Cloud Intelligence Group, President of International Business, Alibaba Cloud Intelligence Group, to deliver welcome remarks. Welcome.
Thank you all for coming to the International AI Product and Technology Forum. We have a fully packed schedule and a super exciting schedule as well. We have our leaders from the R&D and the product side to kick off the session and to discuss with you the details and the progress we have made in the cutting edge of AI technology and innovation. So we will begin with infrastructure and overview of cloud plus AI innovation we have done, and then we will dive into the topic, each topic in depth, ranging from our platform for AI Pi to Lingjun infrastructure to Model Studio to large language model, you name it, all the way to agentic AI, how to develop and deploy agents. So I'm really looking forward to this forum this afternoon, and thank you all again for coming to this session. I'm sure you will find a useful and truly exciting content. So without further ado, I will pass the time to the speakers. We truly have a very strong team of speakers. I'm personally looking forward to it. Thank you all. Thank you.
Thank you, Dr. Li, for the inspiring start. Now, we move into our first segment, upgraded cloud services for the AI era. First up, discussing reshaping Alibaba Cloud for AI innovation. Please welcome Alex Chen, Head of Product, Elastic Computing and Storage Services, Alibaba Cloud Intelligence Group, to the stage.
All right. Hello. Well, good afternoon. Day 2 of Apsara Conference. Before we get started, can I get a raise of hand if those of you who attended the day 1 main event in the morning, where our CEO talked about the roadmap to the ASI, the artificial superintelligence. Can I also get a raise of hand if you attended the day 1 afternoon event, listen to all the product leaders and general managers talking about the product updates? Okay, less number of people. So my role is, think of me as another AI model, and the AI model is called product manager. And this AI model's function is to ingest and to distill, as well as to summarize all the 5 hours of product updates that were delivered in 5 hours, and then translate and deliver back to you in about 28 minutes. So without further ado, let's crank up the token output rate and let's get started. Okay, so you all may have heard that, in terms of our global footprint, we're at 29 regions and 91 availability zones. But also by the end of 2027, we're planning to expand into 8 more additional regions, as well as 33 availability zones. And our global data center footprint in terms of data center capacity by end of 2027 will expand 4-fold. So this represents a significant investment, our $53 billion in the next 3 years. At the same time, we're upgrading our network capability as well, interconnecting all these data centers, for example, to increase our internet capacity, bandwidth capacity, as well as especially around, for example, Tokyo, Hong Kong, and Singapore, where these financial centers, customers need ultra low latency through underground cables or through microwave or through those hollow core fiber optics, we're able to improve the low latency to as little as 40 microseconds. And in terms of software-wise, we're also proactively probing all these network routings and then able to basically switch with a sub-second level and improving the overall network connectivity and robustness and significantly to enable, and this is what we call the route technology. And the route technology really started initially maybe about 2 years ago when we were connecting between regions to region, and then AZ availability zone to availability zones. And this year we're really deploying across connectivity between services. So all these network will enable us to have a global one central network enabled to host all your services. At the same time, you may ask, what is our product, how is our product differentiated? What are the challenges, or what are the benefits of Alibaba Cloud technology? So Alibaba Cloud really start from the hardware, and this is our little graph down below is our CIPU 2.0. And we say it's CIPU 2.0 just to make sure we confuse people. It's really our 5th generation of hardware. And this is developed as a CIPU stands for Cloud Infrastructure Processor Unit, and its purpose is to hypervisor offload as well as provide I/O and storage acceleration. Today, it also provides encryption offload so that you can have encrypted VPC without any performance degradation. And on top of that is our self-developed, across 15 years of storage, compute, and networking software stack. And they said, hardware eventually fails, software eventually works, and it took us 15 years to really make this work perfectly in Symphony. And the other thing I would like to emphasize is that all of our infrastructure layer product advantages are fully exported by our PaaS layer or our upper layer, and so that the complete technology advantages are fully explored all across the entire stack, and working together end-to-end solution to provide the best value as well as the best performance to our customers. So let's go through some of the scenarios. We talked about AI innovation. Of course, we talked about the roadmap to ASI, the superintelligence. But fundamentally at core, what is enable ASI is our Lingjun AI supercomputing cluster, which is able to connect 10,000 GPUs together in a single cluster, 100,000 GPUs in a single cluster. And also, but you say, hey, everybody does that too. You can hear from other hyperscalers. So what is really differentiated about our Lingjun? So I will propose to you 3 points. One is, when we designed this infrastructure, we really designed for multi-tenancy. It's different than just renting out a set of hardware for a month at a time. It's not monthly hardware rental. This is provided to our customers as infrastructure, as a service. You can turn on the Lingjun service in as little as a few minutes. And it's able to host all the different, our customers' training workloads, because we do host about more than 50% of innovations around model training in China. The second differentiator is that as we're moving more towards a mixture of experts, sort of architecture, it is also optimized for not only training, but also inferencing. And more of our customers using the same set of sort of hardware and architecture to be able to run both training and inferencing. And maybe you're running inference during the day and you're running training during the evening. So this product is optimized for both inferencing and training. And third is, if you think about the difficulty with creating a huge AI supercomputing cluster, one of the statistics I would offer you, you may not have heard it before, is that GPU failure rate, according to our statistics, fails about 500 times more than CPU. That's not 500%, that's 500 times. So why is that? Because you're using all your GPU to the extreme, and then GPU itself could fail. And if you're running a single cluster of thousands of GPUs, any of the GPU failures will then stop your job. So how do you ensure to have your infrastructure run smoothly with all this incredible high failure rate and still maintain the coherency of locality of all your compute? So this is the challenge that our product faces, and we would proactively be able to detect 98% of different type of failures and dynamically provision different reliable resources, and yet keep computing close cluster together, enable your customers to run your effectively training up to 99% of your training time. And this 99%, really, this is at the top end of the world leading in terms of what we'll be able to accomplish. It's sort of like, if you think of launching rocket into space is hard enough, but this is actually equivalent to be able to also retrieving the rocket back to your base. And this is our state-of-art technology of our Lingjun cluster. But then that's not all the Lingjun cluster, and most of our computes today are provisioned through containers. And the way we're thinking about containers is not just about the orchestration and the management layer, but also we're thinking of computing as container native computing. So the computing resources provided to container natively and optimized for container. So you can provision a pod via the YAML file as little as 0.5 core and 1 gig of memory, then expand your pod dynamically vertically into 5 core or 5.3 core or 5 whatever memory as you need it. And you can scale out seamlessly as well based on, for example, CPU utilization rate or time of the day. So this is really a scale out and scale up and scale out completely flexible, composable infrastructure. And not only that, we're introducing the ability to basically hibernate your pod. And you may say, why do you want to hibernate those compute pods? Easily. For example, if you're running agent inside a pod and your customer goes away for 3 hours or go to sleep for a day, then they come back. So you don't want to go through all that computation again. You want to be able to reawake the pod and go back where pick up where you started. Where you left off, rather. And this ACS product we GA'd officially last year during this conference, and today, on a daily basis, we are already able to, statistically speaking, basically spinning up 10 million pods in the production environment by our customer. And the other number that noticed here is the elasticity to be able to spin up 15,000 pods per minute. And this is not just a marketing number. It's actually, when we go to POC with our competitions, we can actually prove it to our customer, and our competitors can only deliver half as much in terms of number of pods able to spin up in a single minute. So this is our compute sort of update for AI. But now let's talk about storage. So in this age of AI, storage requirements different. We require a very large file system that can host billions of files, and then to be able to feed all those GPUs simultaneously. And this year, our lead with product is Cloud Parallel File System. But this year, we're actually introducing essentially a same namespace, but data placed across 3 tiers of storage. You could have the highest performance tier close to your GPU, in the local SSD, and then have a distributed cache layer to basically, it's a recache closest to the GPU. And also when you have those inferencing, you basically have a disaggregation of prefill and decoding, and then you connect it with KV cache. If your KV cache overflows your video memory, you can offload to this cache layer as well. And then our high-performance file tier, we expanded this year to 20 petabytes. So 20 petabytes of all-flash high-performance file where data is completely evenly distributed across all the nodes, all the storage nodes. The file metadata is completely distributed, and even the file handles are completely distributed. All this to enable parallel file system access. And then a lot of our customers, their data grows over time, right, into hundreds of petabytes. And when you do that, your hot data doesn't have to be, maybe it's only 20% of your data is hot. So you wanted to basically move that data seamlessly to object storage, yet maintain the same file namespace and seamlessly recall from object storage as needed. This is a way to reduce your overall cost and still improve your performance. But then this year, we're also introducing, very excited to tell you about, we're first time ever we have introduced a new type of bucket. It's called a vector top bucket. And the reason we are doing this is because if you look at our object storage today, there are trillions of object storage on object storage, and most of the customers in a single bucket can contain over 1 billion objects. But how do you, and those objects are all usually, unstructured data. How do you search for the right data, right? If you're like me, I can't even search for the right PowerPoint. So how do you search for all the content? You have to be able to understand, and the way to search for the content is by vector. But if you were to vectorize all your unstructured data, you realize your vector data will be as big as your original data, sometimes even bigger. So we need a way to to store these data at a low cost and yet provide sort of a low-cost query capability as well. Of course, you can store your vector data in database, which is most people do today for higher performance, but this is a way to basically vectorize massive amount of object storage or unstructured data and containing object storage. And also in object storage, today is people using object storage as the base for data lake. Running big data analytics engines on top of the data lake all the time. And so all of a sudden, your object storage not only houses your big data applications, but also houses your AI workloads. So you want it to be able to distribute amount of performance from your single bucket, essentially your throughput out of the bucket to the right workload. Sometimes you want your AI workload to run faster, so you may allocate more bandwidth to AI workload. If you want your big data jobs to run faster, you can adjust it dynamically. And this is how we're talking about the bucket quality of service bandwidth allocation. And also, what we're doing is, if you think about object storage, it is regional service, right? You don't know which AZ it is in. But we're introducing the OSS accelerator that's AZ aware, because you know where your GPU are and all your computes are. So you can accelerate from a regional service to AZ specific or availability zone specific services and to provide strong consistency data. You don't have to compromise on the data itself and service your GPUs or CPUs. We're also, so now that we have buckets, now that we have vectors, we're also upgrading our object storage into content aware. And I'm very excited about this because this is going to be the industry standard for storage going forward for the next, I would say, 10 years, where we're turning object storage not only as a place for data placement and object storage, but also turning into a knowledge base, where you can basically self-discover the content that you have, and you can use an agent basically call and retrieve the content. You don't have to know about what your data, which files has what data. And also, anytime when you have a new data, you can say, for example, anytime when somebody's uploading a picture or a video of someone kicking a soccer ball, please notify me. So we could do that as well. So any incremental data gets uploaded to object storage, we will automatically discover its content and alert you as well. So then let's talk about networking. And there's 3 sort of upgrades on the networking that's associated with AI. One is ALB, which is application load balancing. This is our sort of layer 7 load balancing, historically looking at the TCP/IP header and be able to balance across the different applications. But also we're now doing this for token as well. So you can, when you're having inferencing, you can also do load balancing across basically your different models. And then because your compute is sort of located in different geographies, oftentimes you need you basically transfer a huge amount of data across a vast amount of network. And then GA, or global acceleration, is very good networking capability that allows you to accelerate your data transfer across network globally. So 2 upgrades to the GA is or global accelerations. One is the built-in WAF capability. So basically, it has its native firewall protection, and also the Anycast capability. Basically, in a whole entire world, you can have one IP address, and it will decide where your close proximity in terms of access automatically to have the close proximity routing as well. So then you have besides the storage, compute, and networking, and on top of it is, of course, our container orchestration. When important thing about container orchestration, you want to manage all your resources, right? You want to manage all your Lingjun resources or ECS resources located in different parts of the world. You want to have a view of where all your resources are and to be able to orchestrate and to manage your task, assigning which tasks running on which resources. And if you're running inferences, you have maybe some of the pods that are doing prefill, some of the pods are doing decoding, and our inference gateway is KV cache aware. You will route to the right, basically, set of worker groups as needed. And so it's centralized, basically, management enable you have a single pane of glass to orchestrate your containers. And then on top of containers are our Pi, which is platform for AI. And very excited about we're introducing Pi Prime, and under Pi Prime, we're introducing 4 basically training frameworks, and it's optimized for each of the frameworks in terms of MOE training, reinforced learning, or Fuse. And then these, if you're using Prime and using these training frameworks, you'll see your training time up to 3x speed up. And our Qwen models are all trained on Pi, and so this is a testimony of our capabilities. And all these Pi capabilities are encapsulates all of the underlying storage compute network capabilities as well. And then in terms of inferencing, with the Pi EAS, it's a cost effectively for inferencing nowadays with billions or hundreds of billions of parameters. Inferencing becomes a challenge as well. You wanted to have a high-performance network to host all the different compute capabilities and then link them together. And then perhaps you want to optimize your inference to have lower time to first token, or you want to have your inference to optimize to have a lower time per output token, or you can optimize the throughput. But the key is that in order to go through this very complicated ML ops, you can just use Pi EAS and adjust this dynamically. You can either, given a set of finite resources, you can either optimize for performance or optimize for throughput or customer experience. So all that could be adjusted dynamically to suit your needs. And then you need to have end-to-end to really productionalize your AI. You need to have end-to-end monitoring. This is all the way from application down. You want to be able to understand how much resources are being consumed per each user or per each token. You want to understand if you do have a slowdown, right? We say slowdown is the new slow is the new downtime, right? You wanted to optimize proactively your performance. And you wanted to be able to make sure that your data is moving in a secure fashion. So all this end-to-end monitoring, a single pane of glass, will enable you to manage your operation across AI. So in conclusion, on the AI aspect of it, we have updated the whole portfolio with all these functionalities, and they're working together in cohesion to provide a complete AI platform for your AI innovation and workload. But it's not just about coming up with new applications. It's also about connecting AI to your existing environment, to train your AI based on your existing data and to optimizing your existing workload and to achieve higher efficiency. In terms of database, we have encapsulated all the AI capabilities in the database through SQL, SQL query, or API, so you'll be able to process your AI in the database. Also, at the same time, all of our database, the majority of databases such as PoloDB, ADB, and Lingjun have upgraded to serverless architecture to not only be able to spin up CPU resources as well as GPU resources in a serverless fashion, increase the performance and efficiency. Also, at the same time, all the databases work with object storage as well, so deliver multimodal type of analytics as well as search, and reducing the overall cost by offloading some of the data to object storage. So then if you're building a RAG, so a lot of people are building an enterprise RAG. What do you need an enterprise RAG? You need an enterprise RAG you build with vector database, but also you'll notice typically a RAG will only be good for a certain domain and searches within the domain. You'll need a graph, knowledge graph to basically connect the RAGs to have this semantic aware search. And building these complicated knowledge graph is very costly and it's a daunting challenge. So, but we enable that with our database to connect with our the AGE, basically our Postgres plugin for graph database with all of our databases, and our databases also natively has the capability of vector database capability as well. So putting this together, you will be able to basically have a higher precision on your reg with graph reg, and also reduce costs as well. And so even though you have a number of choices on your database, depends on your workload, you optimize for different type of database, but you need only one platform to manage them all. And this platform is DMS, to manage all the metadata, to manage all the data governance in the database, and also have unified data ops and agent. And also you need only one platform to basically process the data from your enterprise data to make them AI ready. And that's our DTS one channel to be able to embed, to do vector embedding, and to basically feed those into the databases and make them available for AI applications. And then to our big data architecture, last year at Apsara conference, we announced our Open Lake solution architecture. Basically, it's able to ingest all these different formats of data, whether it's PEMA, Iceberg, Lens, or the more of a traditional OCR or POQUE, those type of data format, into one data lake, and then you're able to run your batch processing or your stream analytics, all that with different type of analytics engine. And then you manage essentially all your data development using DataWorks. So Max Compute does just that, and this is our lead with offering on batch processing. But not only Max Compute does all the batch processing, now it's also able to offer nearline query, near real-time processing as well as incremental processing. So incremental computing. So Max Compute also incorporate all these AI functions and capabilities which you can invoke via SQL. So it becomes not just for a big data engine, but also AI engine as well. In terms of Holograph is our real-time analytics engine, which delivered really low latency, fast real-time response on these analytics, and it's also upgraded with AI capabilities and AI function operators to simplify AI development inside of this big data engine. It also works with object storage to be able to essentially consume the object tables, and so it's not only for structured data, but also semi and unstructured data analysis as well. And then, as you know, Alibaba years ago acquired Viverica, which is basically the funder of Flink. We're also upgrading Flink with another community-sponsored Flus, which is basically, if you look at stream analytics, it never really had a storage. And Flus is basically storage for stream analytics. You can contain storage maybe in 7 days and rotate it around, but in that 7 days you can update those data and you can have those column-based storage and speed up the query, as well as all these updates will have change logs. So in one place you don't need an ETL, and it's more efficient than perhaps the open source Kafka. And we also, in terms of our compute or big data analytics engines, host all these open source analytics engines. But we have our own version, enterprise version of these open source engines, such as EMR Spark and Starrocks. And our differentiation is that even though they're the same as the open source, but we improved the performance by 2x. So that's a very substantial benefit to compare to if you were building your own. So when we think about data development in the age of big data, right? You have all your data assets that you manage, and then you feed into different analytics. But today, the same set of data also feed your AI machines. And if you were taking all your enterprise data and you were to come up with a really, really, really good model, you want to be able to go back and say, okay, which data did I use to train this model on? And you want to be able to centrally just not only develop your do data development for your big data applications, but also for your AI applications. And DataWorks enable to do all of that with basically the IDE environment and the notebook environment. And then let's switch finally to another gear in terms of high availability and enterprise applications. At the end of the day, that's our bread and butter. I hate to say it, some people view it as traditional, but this is still very important to our enterprise. So our posture on that one is that we want to deliver value to our customer where it matters. Not all applications require highest performance. So we have upgraded our U instance, basically our universal instance. These type of instance, you don't know, we abstracted the CPU, so you don't have to worry about which generation CPU that you're on. You can think about, take all your tier 2 applications, office applications, load onto a truck and dump it all on this U instance. And it will just run flawlessly with very cost-effectively measures. And our U2 instance with both U2i for Intel and U2a for AMD, basically they were up compared to U1 instance. All the performance are seeing, the baseline performance is see a dramatic increase up to 40%. But also on top of the baseline performance, it's able to burst the compute performance, the storage and network performance about another 20%. And the cost of TCO of that is also reduced dramatically. So this is, for all your back of office applications, this is the best platform to run those type of workloads. And then for enterprise applications or databases, we recommend our Intel-based offering based on 9th generation ECS, based on the latest offering from Intel. We see a 20% performance improvement, and also we reduce the list price by 5%. So you truly get a better price performance across all. And then we upgraded our AMD instance as well for first time ever, also first time ever in Alibaba Cloud, but also in our the Chinese hyperscalers. We're introducing a physical core type of instance with hyperthread turned off. So you may ask, why did you do that? Because we noticed a lot of the customer will get benefit when they're running big data on AMD. And those big data workloads are memory intensive. By turning these physical core off, you will reduce the noisy neighbor problem, and also you will make sure the memory, basically, memory bandwidth consumptions are equally distributed. So when those numbers are not just spec numbers, they're real life scenarios, or customers are seeing, the real customers are seeing a 43% increase on big data workload just from one generation of AMD instance. And then our PoloDB also have a innovative approach as well. So we talked about storage and compute disaggregation, separating the storage from compute so you can scale independently. But also with PoloDB, you can scale out memory as well independently with the CXL technology that you can use remote memory as if it's local memory, and you can expand all three type of resources dynamically as needed. And this type of basically hardware architecture and the product architecture enable you to run the highest performance possible and setting the world record for TPCC. And also with PoloDB, you are able, used to databases just one single writer but multiple reader, but now you can have multiple reader and multiple writer. So performance is very important, but it's not everything. Reliability is especially for data, availability and reliability is important. You want to be able to have your data to be protected against zone failures. And when we do have a zone failure, you want your data to be distributed, have RPO and RTO equal to 0. And we have availability of our object storage in basically 3 availability zones, but also in 2 availability zones. EBS, if you choose a regional EBS, without changing any applications, all your data will be distributed across 3 availability zones. And because this is such an important technology, the PaaS layer in terms of databases, in terms of backup, all incorporates this type of capability. And all the snapshots are zone redundant. So if you take in the snapshot of your block storage, and if a zone goes down, then you can recover in another zone. And the same with our database, to make sure that databases are also locally redundant, regional redundant, and across global with active capability. And of course, with our big data analytics engine as well, with max compute. And then let's talk about security. So security is very interesting in the age of AI. One is security itself is evolving with not just rule-based security, but also AI-enabled security. About 80% of our security today are still rule-based, but 20% are now enabled by AI. In this working in combination, we'll be able to provide the best security to our customers. And we are also using security for ID identification to provide facial recognition and deepfake as well. So a lot of the AI generation will generate facials or videos of someone that's not real, and we are able to basically use this deepfake detection to understand if you're real or AI generated. And as more and more customers running workloads, we basically use AI Security Center to take a full inventory of what are the AI assets that you have, what are the models that you have, and what models, and be able to scan all these models to see what are the backdoors on these models. And if you're using a polluted model and then you train another or fine-tune another model on top of your enterprise data, and the model that you came up with is also have those same backdoors and security vulnerabilities. So with our security center, we will scan full inventory of your AI assets and to provide you a comprehensive view of your security posture. And in terms of inferencing, so you could inferencing things that are not, you could generate malicious code in terms of the AI model, and your output could be problematic in terms of content that may not be, it may not be, or it could be violent, or it could be whatever. It may not be kosher. So all this AI capability with AI guardrail that we announced this year is able to basically govern, and I guess across the door as well, talking about responsible AI to manage these inferences as well. So finally, it's not about just running your enterprise workload. It's not just about running AI, but it's also using AI in our Alibaba Cloud products to make our product usage so super simple. So when we're talking about using AI historically, right? If your SREs or your maintenance team, they would have to sort of understand what data is producing. They will have to process the data and figure out what the problem is, and then come up with sort of a task to figure out what to do. With Copilot, basically we're enabling our SREs or maintenance team to be able to ask the system in a natural language form. Then we will try to attempt to understand the data and provide basically the data to the maintenance SRE. But in the age of agent, basically your SREs will just need to set objectives, and your agent will execute those objectives automatically. So it's more and more agent or AI is able to take those responsibilities and less involved with human. And we're doing that with AI agents across all the products, such as object storage, ECS, and network. But more importantly, you need an agent to basically run across all these products to have a comprehensive AI operation. So, and also in terms of databases, we have agents that manage across all your databases, as well as if you were to using an agent to basically process your data, you can set your goals, and it will understand in terms of natural language what you try to do, and it will check all the required information, you set the plan, and then you will execute the plan and generate the output. So, in conclusion, all these products updates basically summarized into 3 key points. One is our technology leadership across the stack, integrated horizontally and vertically. We are investing heavily across the world with our current largest scale in AP, but geo expansions in parts of Europe, in North America, South America, and Middle East as well. At the end of the day, we want to provide cost-effective, comprehensive solution to our customer, able to accelerate your AI innovation, to be able to revolutionize your data intelligence, and facilitate your enterprise workload. Thank you.
Thank you, Alex. Next, to talk about efficient and integrated resources for AI computing, we have Zhangzhu Ong, Product Solution Architect, Alibaba Cloud Intelligence Group, discussing the Lingjun Intelligent Computing Cluster.
Thank you, Alex. Thank you. So I'm an agricultural engineer from Lingjun product. So today, I I'd like to talk about something we are all deeply involved in, the evolution of AI inference array of large models. Actually, we are in a turning point. Models are no longer just about staking parameters, and they have evolved into trillion scan spiral architecture, and MOE is no longer experimental. It's production grade. So models with tens, hundreds, or even trillions of parameters have been trained, served, and deployed into the real applications. But with this progress, has comes new challenges. As monster grows larger, training becomes more complex, and inference demands a lower latency. So how can we make our underlying system keep up? That's exactly what I want to explore today. And the next few minutes, I will talk you through this trade, architecture, innovation, and elastic operations to make this possible, from new performance to system-level intelligence. So in the past year, we can see MOE models with trillion parameter has over 100 experts. They are not a dense model like every parameter fires on every input. It only active relevantly expert per token. And it will acceleration efficiency, but also introduce new system-level complexity, just like routing across hundreds of experts during training and lower latency decision-making in inference. And the compute, memory, and network must be optimized. So training compute demands have increased by nearly 4 times under the comparable workload. This is not a linear scaling. So simply adding more GPU will not solve it. We need a different approach to infra design. Actually, we can see a clear difference on the training side. First is a billion parameter dense model still guiding the NLP per training. And second is the trillion parameter MOE models is going to production, such as versions of a Qwen and DeepSeek. Multimodal and autonomous driving simulation also bring more complexity. On the inference side, the characteristic is even more special. Smaller dense model handle lightweight, high currency, service, and the large MOE model face challenges in routing overhead and load imbalance. Multimodal inference requires cross-modal alignment and smart caching. The point is, one cluster may run pre-training, SFT, reinforcement, and A/B testing. So it's hard for us to operate in it. So our version is to break down the wall between training and inference cluster and build a uniform platform for AI workload. So Lingjun comes. So actually, this is a cluster product, but not just another GPU pool. It's an AI native compute platform designed around the task lifecycle, built on the principle of affinity. So what do we mean about the affinity? I think we can define it bringing together the right resource into a close integration, high-performance operating unit. So Lingjun has achieved this through 4 layers of affinity. The first one is scan-up affinity. We can provide high bandwidth GPU interconnected within the instance. And the second one is scan-up affinity. RDMA high-performance network enable every instance expansion up to 3.2 TB per second. We can scan up tens of thousands of GPU with microsecond level latency. And computer storage affinity, anti-interference design of the storage network. And the last one is self-healing affinity, multi-tier fault recovery from collective communications. So for example, if you want to start a 10,000 GPU task, you can set up a task group in second. And this is the true out-of-the-box really means. And now let's look at the two often overlooked but mission point, the compute storage affinity and the self-healing affinity. The first is compute storage affinity. Traditional setup on CPFS, EBS, and VPC traffic over the same NIC card. This the moment a massive checkpoint begins rating, your training job will be affected. And we have set it, we know operating like or reduce fails if even one node lags. A standard VM restart strategy will not solve it here. So Lingjun different, we detected different. The communication patterns and applies intelligent recovery from like hot spare, soft migration, code failover, always in minutes. And we preserving topology as much as possible. So great architecture means nothing if you can't deploy it quickly. So we have here the feedback. Your technical is impressive, but I can't wait 3 days to set up a cluster. So we have optimized the deployment, just like some method. Lingjun now has support HP in zone. The user can one-click create a Rocky-based lower latency network demands. And you can define node group from your training or inference and start a Linux 3 image with pre-install toolchains. And we support ACK integration, seamless access to a cloud-native ecosystem. The most important, a 10,000 GPU cluster can be fully configured in hours end-to-end. This was unthinkable just a few years ago. And now, whether it's emergency scaling or testing, you can get a lossless scan of testing. You can as easily as starting a container. Except for the bare metal, we have deeply integrated upstream and downstream tools, just like ACS and ACK integration with cloud-native AI inference kit. Prefilled and decode separated inference acceleration to be reduce first token latency. And in the past, training and inference is run on different clusters. If you want to train a model, exploit is pretty costly. The efficiency is really low. And now we have bring the situation. Lingjun support uniform cluster as the 100,000 of GPU scan. You can run both massive pre-training and hand-throw pod online inference. We have practiced large scan scaling, and we can reduce cross-node hop. We have achieved about 99 effective training time for trillion Prometheus MOE models. Almost no downtime due to the network failures. And look ahead. The next leap is a hypernode cluster. A hypernode is not a physical monster server. It's a logical integrated unit composed of multi-standard nodes behaving as a single high-performance unit. So what is the advantage? So the advantage, sorry. So the advantage is we can get So in the past, the training and inference is runs on different cluster. So if you want to train a model expert for the effective cluster, and now we have breaking the situation, and the Lingjun can support the unified cluster at 100,000 GPU, and we have participated large-scale EP optimization for MOE interference. And we can use topology-aware scaling. We can reduce across nodal hops we have achieved due to 99 effective I have introduced. And looking ahead, the next leap of the hypernode in this page. A hypernode is not a physical monster servers. We have give a lot of advantage, just like large scaling guaranteeing with reduced fragmentation. And full mesh communication benefits out of all ops. And we can offer the flexible HBD adapter for various parallelism strategies. It's just like a NUMA computing nodes distribute scalability with the nearly single node efficiency. Of course, the root of a hypernode is still complex. So we have identified 4 challenges at least. The first one is growing deployment complexity. Shannon's law has replaced Moen's law. So performance comes from system, not insisters. And balancing the peak performance with usability, like scenarios switching hard. If you want to switch from the training to inference, you must reconfiguration, you must re-network, reinstall, and it will become too slow. And the last one challenge is stability at scan. With tens of thousands of GPU, too much failures. So how do we reduce the downtime? So how does the hypernode actually work? It may be about the flexible HBD configuration, like 4 GPU, 8 GPU, or 16 GPU. And the users can define customer policies through the console. The metadata sharing allows from between the hypernode and the child node. Your health status, your load metrics, your topology information to enable starting the scheduling. And internal is complexity, but the user's experience will be really simple. The standard cluster creation, group scaling, and configuration image rollout. But for the biggest challenge, it's still the stability. As the incorrected domains expansion, small issue can cascade. We also should implement a 3-tier handling progress. Tier 1 is how to repair, no task interruption. Tier 2 is soft migration, topology preserved. And Tier 3 can be the code failover, friendly feedback, and the goal is minute leave recovery, 0 job interruption. So finally, we can walk through the self-healing loop. When a node failed, step 1 is health check, triggers and report the status. And step 2, system analyze event and match scenarios. Step 3, hitting engineer decision on the how to repair if it work or not, and stop migration. And then notice the Kubernetes control panel. And step 4 is new node repaired and strongly affinity recovery. And step 5, the users can notice the loop will completely. We also provide the CMS operations platform for SRE teams to dive deep when needed. But for most users, their experience is simply, your job is keeps running. Okay, to sum up, we are undergoing a transformation in infra from raw compute to intelligent affinity system design. AI is forcing us to redefine what is usable compute really means. Lingjun's mission is simple: make training trillion parameters models as few as easily as running a script, and make a complex MOE inference as simple as loading a web page. It is the beginning of a new chapter. So, hope we can bring competitive and continuously evolving product. Thank you. Thank you for listening.
Thank you, Mr. John. Now, on the topic of unleashing AI development efficiency, please welcome Lin Wei, Head of Platform for AI and DataWorks, Alibaba Cloud Intelligence Group.
Does it work? Seems too much. Please change the script for me. Yeah, I don't remember. Okay, my name is Wei. I'm a head of the platform of the AI, or also the DataWorks in Alibaba Cloud. Today, I will walk through those try to unveil this AI development efficiency in Alibaba Cloud. Okay. Probably you already see these slides multiple times. We have 3 layers. On the base layer is the ICE. We have the computation, the storage, the network. On the top of that is our PaaS. It's basically what work I do. My team is done as I include this Pi for the training and the inference. Also, I include others, the team's work, the model scope for the model sharing, and the Bailian for the enterprise, the application build. Finally, on top of those paths, we have a model as a service to deliver this foundation model as the Qwen and Wanxiang and those domain-specific models to power this vertical application across the financial, the healthcare, the education, and more. Those layers approach actually enable a scale and efficient and accessible the AI innovation for our customer. Training a large language model is not just about the GPUs. Actually, it's about rethinking the whole, the entire system stack. Just unlike the traditional data parallel computation, the large language model training actually brings the 4 key challenges. The first is the storage. The massive data set must be reloaded every iteration in the training, not just once. So, the second, the network. The performance always is bottlenecked by the GPU to the GPU communication. Third is we have a huge, large-scale training job. But the network, we have a scale-up network and a scale-out network. Those bandwidths is different. Our training framework need to be aware of those differences and try to find out the best the distributed parallel strategy to fully utilize all those bandwidths. And the fourth is the reliability. Couple of our colleagues already mentioned that the GPU actually is quite different to the CPUs because we already pushed the hardware to absolute limit. Sometimes we are joking that we're almost melting these silicon chips to just try to maximum this computation power. But that comes at a cost, is that the chance of the error is much, much high compared to the CPU cluster. So we need to handle those failures at the system level. Actually, it's very critical, those challenges we must address in our system. Our workload actually involved very fast. They actually bring some new storage challenges. The first, the large language model actually is adopting those MOE structure. That means that there has billions of the parameter, 10 times the parameter than the dense or more. The checkpoint actually happens more frequently, and the data set actually grows the petabytes of the tens of the petabytes of data. That means the storage layer need to handle the burst I/O and need to provide very stable and low latency throughput at a very large scale. The second, the training need massive the number of some small files. It's not like the big data. You all can chunk this data together and read that in the sequentially. Actually, in the training job, we usually need to randomly access those files, just to get this positive or negative samples, try to merge this model as quick as possible. So that actually brings a lot of the metadata access. So the metadata performance is also critical. So especially that we will deal with some millions of those files. The third, the inference service that need a very fast model loading because the model could become very extremely larger. So we need a high performance storage to provide those model loading. And also, in the inference, you need a global KV cache service in order to reduce the computation, to save this computation resource and improve the inference performance. And first, the computation environment actually is diverse. We need to mix the CPU and the GPUs across teams. We need the enterprise, some security, the data management for our customer. We have to go through this virtual private clouds, the multiple file system, the fine-grained, the permissions across the multi-tenant user. So in a short, AI actually is not just about the computer. The storage also need to evolve very quickly to keep up. Okay, I think this slide is covered by the Alex slides, so I skip. Okay, now let's talk about the network. First, let me introduce our current generation of the data center network. We call it the HPN 7.0 for the large scale AI workload. It's built on this 51.2 terabyte switch chips. It's a dedicated backend network for the GPU connection. Scale up to 100,000 GPUs in a single available rooms. The architecture actually, we actually give a dual plane for the failure recovery. Sometimes some switch failure happened, they only lose the half of the network, not complete down. So by this technology. And we have a real optimized technology to improve the performance and ensure this high reliability through this redundancy. On the left, we have the backend network. We call it this two-layer CLS. What's this? Printed 2. I probably forgot. But the design for optimize this 100,000 GPU interconnections. And with the cross-plane connection to minimize the latency and maximum the bandwidth. On the right is our front end. We actually have a back end and front end, two different network, just to try to separate the AI computation and some other workload, like the storage workload. Because the computation needs to be is very sensitive about this latency and the throughput. We don't want to disturb by this storage traffic. On the soft layer, we have integrated our, we actually introduced our communication library. We call it the Alibaba ACCL, just like ACCL. It is a global optimized and topology aware the communication library that's we build on top of our, they can run on top of this commercial, this network like the BF3 or our in-home we actually introduced our own this network chip is LEAPS. That's how we actually deliver the very stable, high performance and reliable network. Okay, this year, things actually continue to change. The AI workload, previously the AI workload, the network is mainly optimized for either the training or the inference. But now, actually, the thing is different. With the next generation of our network solution, we are breaking this barrier. So this is probably the first unifying the architecture that we designed for this mixed mode. We actually high throughput for the inference, low latency for the inference, and as well for the large scale, the training as well. So it's powered by the next the 102 terabyte switch, the 500 gig leaks, and the self-developed silicon, the photonic, and the HPN 8.0 delivers the massive bandwidth and the low latency. So we also, for the inference, this generation, we actually introduced some cross-room, the RDMA, and with the QoS and the traffic control schedule to ensure the performance actually isolate and efficient load balanced. So they can both support this large-scale inference as well. Okay, training large language model at very large scale requires the intelligence scaling across the three different layers. The first, we use the compilation technology to optimize this parallel periodization. We analyze the model model structure like our Q3 and decomposed it into the date and the tensor or pipeline parallelism across the thousands of the GPUs. The second, the job actually needs to placement. We map those this parallelized task to the physical hardware to optimize this network topology and the resource availability to ensure this this job can efficiently to execute. The third, the local at the single GPUs, the local execution also matters. We need to be careful to schedule those operators to make sure that the GPU actually we fully utilize the memory of the GPU, those SM of the GPU for example, this how to efficiently to use the matrix multiplications to maximum the computation utilization and minimal this idle time for the GPU. Together, we are actually achieve very high performance training for the large language model across this cluster. Okay, for the inference part, oh, no, not the inference part. For the training part, the training next generation model like the Q3 requires more than just the scale. Actually, this demands currently this trend that the long context understanding and this complex reasoning enable this genetic AI behavior such as planning, tool use, and multi-step decision making. To support that, we currently moving to the MOE architecture, but the MOE actually introduced some challenges. They introduced this sparsity, introduced this dynamic routing. This brings those challenges also opportunities. So for those illegally the computation pattern or load imbalance, how we deal with those imbalance and how to make the system to adaptive those imbalance or the illegal computation pattern and then can fully utilize the computation resource is our opportunity. Also is our challenge. To address that, we actually developed our Pi MOE, uniform the framework for the efficiency of, especially for the long context MOE training. It combines some technology like the model trunking, the data trunking, overlap trunking to hide the communication, the latency to maximum the CPU utilization. You can see from the results, the MOE, our Pi MOE actually achieved up to 3 times the high training efficiency on the Q3. Okay. Talking about the reinforced learning. Reinforced learning actually is the key to build this generic AI system that they can plan reasoning and interact with the very complex the environments. Our Pi-RL framework is designed for a very flexible, easy to use, and highly efficient. It built on this Ray, some distributed Python program library, and support this multiple backend like Q, DeepSeek and Llama. It is also supports diverse environment from the coding sandbox, Jupyter Lab, or the browser, or the games, or this computer use to enable this real-world agent training at a scale. With the feature like we have dynamic batching, sequential packing, those asynchronous reward computation, just try to overlap this rollout with the training. We are enabled to achieve that 2 times the higher the throughput than the baseline framework. Okay, large language model also lead a distributed inference. Inference is not just one fit all. We can use one technique to optimize for all these different model, because the different model has a different structure. Also, on the different chips, there has a different constraint. Taking the DeepSeek V3 and the Q3 as an example, both are large language model, but the structure actually is different. For example, the DeepSeek is using the MTP, but in Q3 we don't have MTP. We have to use this ego to try to predict the next token. So we have a bunch of different technology. For example, we have export balanced placement. We optimize this DP balance or EP balance as well. For the Q3, we actually has to leverage to justify this computation operator. We have to do more. For example, we have to do the FP8 combine operator in the previously probably. In the DeepSeek, they don't need to do that because our pipeline is slightly different to the DeepSeek. We have to put more, save more computation on the combine to try to pipe this pipeline more tightly. So with all this technology, we can save a lot of improve the efficiency of the inference a lot. Okay, the last thing is about the failure. So in the large language training, the failure actually is not it actually is quite normal. So we see frequently the hardware issue like the ECC errors and NVLink error failures, especially across the sound of the GPU. It can cause the harm, sometimes the slowdown. Sometimes more difficult problem is the silence. This we call it a great failure. You don't know what exactly there's a failure. There's no exception. They just slow down. So as shown under the top graph, the training actually speed sometimes get jitters a lot, disturb the performance. And the bottom graph is shows that the training job actually repeatedly interrupted. The one failure actually will stop the whole job and force the job to recover. So how we deal with this problem. So we actually actually separated this challenge into two core challenges. The first, how to detect those gray failure or silence those slowdown quickly. Sometimes it's very hard to tell where's the problem. Is the GPU problem, is the PCIe problem, or the switch problem? The second, once we detect these failures, we have to very fast to recover from the failures. We need a fast checkpoint and recovery. So, but there's a trade-off. Frequently, the checkpoint actually adds runtime overhead. But infrequently, that means once the failure happened, you have to lose the hours of the process. You have to roll back to very, very early stage, and then to continue to repeat this training phases. So we need to some smart detection and low-cost recovery. So that's what we do. So to track that, we actually introduced some dual diagnose approach. The first is a faster diagnose. We collect the real-time job logs and mine those errors, the messages, and quickly to narrow down these effective GPUs to identify those issues in the cluster. The second is a deep diagnose. So when the slowdown happened or the failure happened, sometimes we will trigger on demand some E2U link profile. And test this to point out this root cause. So by combining these two approach, we can let us to automatically locate the problem across the thousands of the GPUs and migrate the jobs in minutes. So to minimize the recovery from this failure, we introduced two technology, asynchronous checkpoint and on-demand checkpoint. So the asynchronous base means that we overlap the checkpoint with the computing. We split the weight into tensions and save them to the GPU, to the CPU, let the CPU to incremental to do the checkpoint. So by this way, we are not block the training. With the on-demand checkpoint, we copy this state to the local CPU memory every iteration. We are not persistent the storage when the error happened. So when the error happened, we are not stop the process. We actually trigger the CPU, some CPU program to quickly to save their state in the CPU memory to the file system. So by that way, we actually can break the trade-off between this performance and the reliability. So to enable some efficiency, low-cost failure recovery in a large training. So that's the end. Pi is a unifying and end-to-end AI platform from the edge compute and the network to the PaaS service and the mass solution to empower the developer to build and train and deploy this intelligence application at a very large scale. Okay, thank you.
Thank you. And for a real-world application, we have added to Pertomo, Senior Product Manager at Goto Group, sharing insights on Goto migration, leveraging cloud infrastructure and services for digital innovation in finance. Welcome.
Hello, folks. Ni hao. Sure. Hello, my name is Aditya Pratomo. I'm product manager in the Goto Financial Infrastructure team. And today, I will share you some of story about how we migrate our infrastructure to Ali Cloud. Okay, this is going to be quite lighthearted, so let's be less serious, okay? So, about Goto Financial, we are one of the largest fintech companies in Indonesia, offering a wide range of secure and responsible financial services for individuals and businesses. Our range of product includes e-wallet, payment, lending, payment gateway, point of sales, and digital identity. And our mission is to drive financial inclusion by empowering every Indonesian to easily manage their finance and attain financial security. Now, having said that, for us as a company, we view cloud infra as a strong foundation for our innovation. Why cloud? Three things. One, cloud infrastructure enables us to speed up time to market. We can push new values to the user. We can push features to our end users without having to experience the headache of managed hardwares. Second thing is scalability and performance. The nature of our product requires requires us to handle dynamic traffic day in and day out. And we see that cloud infra enable us to instantly scale up and scale down resources based on their usage. And this is very vital for our financial product because we have to process every request correctly in a timely manner. And the last thing, security and compliance. We are handling financial data, so it has to be very correct. But also, because we are a financial institution, we are heavily regulated by our government's regulatory body. So we have to make everything comply. No comply, no business. So these three things, these three limitations, basically pushes us to pick cloud infra as the base infrastructure in favor of handling our own data center. So, however, as a part of an infrastructure team, there are three things that we cannot avoid: debt, tax, and migration. I won't talk about that. I will not talk about tax, but I will talk about migration. So here's the story. In late 2024, basically mid last year, our company appointed Alibaba Cloud to be our new cloud provider. And so subsequently, the migration work started on October last year. And I was appointed as the lead project for that migration. No small feat. I thought it was going to be quite scary because when I did some research, I found out that over 75% of cloud migration projects fail. Either they fail completely, or they wait, or the project goes on and on forever, even longer than waiting for Manchester United to win another Premier League title. However, having said that, we see it from the get-go. We have thought that in order for us to be able to successfully complete this project, we require a strong and trusted partner, and we need to have a strong collaboration with that partner. This may sound scary. However, if I fail, I will not talk here in front of you guys. Yes, we've managed to complete the migration. So in total, we've managed to migrate more than 8,000 services, maybe close to 9,000, more than 2,000 databases, and even petabytes of data. We have successfully completed to migrate all of those from our old cloud environment to Alibaba Cloud. In that process, we've also managed to consolidate our cloud providers. Previously, we used a multi-cloud setup in a multi-region setup. Now we've consolidated everything into one provider in one region in Indonesia. And yes, we have managed to complete this ahead of schedule. Not only on time, but ahead of schedule. Yep. We set up about more than 10 months initially, but then we managed to complete it by 9 months. And also, what even more impressive is that we've managed to complete all of this with very minimal downtime. So for our end user, they experience no down whatsoever, no impact to their overall experience of using our applications. Business running as usual, people pay as usual, without having to understand that behind the scene, the infrastructure team and the product team are working very busy to move the services into the new cloud providers. What I also didn't add to this slide is that during that process, we've even managed to launch new features during this migration time to our end users. So that's quite impressive if I see it in retrospective. Now, how did we manage to do that? The star of the story here is two things. One, our very strong engineering culture, and then the two, our investment in our internal developer tooling that enable us to perform this migration in a self-service manner. Here, let me tell you something. On this migration, we don't have the infra team one by one manually copying every service to the new cloud environment. No, but let me hear you one thing. So how did we do this? We do it in 5 different steps. At the first step, we set up the infra. We set up the Kubernetes cluster, Argo CD, the GitLab runner, and everything. And then we set up the infra for the service in the Ali Cloud environment. Okay. Also to add, we follow Alibaba Cloud landing zone design. So we have a very clean-cut ownership information on each Alibaba Cloud project. Second thing is, after the infra team finish setting up the infrastructure, our product engineering team can seamlessly copy their existing services to the new Alibaba Cloud infrastructure, all via graphical UI, no terminal whatsoever. They just need to click, and then the service get copied to this new environment when they do the next deployment. So they can do this in a self-service manner. So at this point in time, their services live in both the old cloud and then the new Alibaba Cloud environment. After that, on the third step, the product engineer only need to do change of configuration. So they now need to point the traffic to go into that new service. Okay? And after that, they can safely roll out the changes gradually. 1% to the new cloud, 2% to the new cloud, 5%, 10%, etc. Up until the last point, they have 100% traffic served on the new cloud environment, and then they can clean up the old services in the old cloud environment safely. So what's even, I think, one of the strong anecdote I had from this experience is that at one point, we even had the product engineering team do all of this on their own without the infra team know that they're doing it. So I think this is a very cool experience, because then I see that how the product engineer can safely migrate service to the new environment with very minimal manual help from the infra engineering team. I think that's very cool. So what do we have from this whole activity? We see 4 different benefits. From the cost perspective, we've managed to reduce costs down to 50% compared to the old environment that we use. Second, because we've consolidated all of the thing into, consolidate the cloud in one single area, closer to our end users, we've reduced the network hops, and in turn, this improves the UX, give better UX for the users, because they can do things more instantly. Third thing is that one of our product engineers actually reported that the database have a 30% performance increase using PolarDB compared to the previous database that they use. And then the fourth one, we have a compliance setup. We have everything in Indonesia adhering to the regulatory compliance, and we have also set up the DR setup on this new cloud setup. So all these 4 things, I think, is a very huge benefit for us, strong foundation for us to move forward in the future, all thanks to the cloud migration. So what do we learn from this activity? I think it's down to 3 things. One, the DevOps principle. If you've heard about DevOps, you know about the terms, you build it, you own it. Now you build it, you own it, you migrate it. As the service owners, you know how best to migrate your services, and we've basically enabled that. How we enable that? Second thing, we've managed to did a lot of tooling investment over the past few years, and I think this is where our investment actually paid off handsomely. We've captured the DevOps principle into a standardized practice that we've captured in our internal tooling. And also, I would like to give a shout out to the Alibaba Cloud, because they've offered a very strong capability of product that basically makes the whole migration, we can basically complete it without any hiccups. I like to point out ECS, the managed Kubernetes, PolarDB, Max Compute, and OSS that plays vital role in our infra right now. And basically, we can just move things and have everything working as is, as we've expected. So, with that being said, we still have some more roadmap in the future. As a new users of Alibaba Cloud, we still need to do a lot of resource optimization to get better better performance out of the resource that we've used. We also like to adopt the latest machine types. We've heard about the 9th generation machine, and I think that this is something very interesting to use. And finally, we want to use all the Alibaba AI capability for us to improve our internal operation. And so, I would like, again, as part of Goto, I would like to thank strong collaboration from the Alibaba Cloud team. And I think this collaboration makes us different from Tom Cruise. Tom Cruise has Mission Impossible, we have Mission Possible. Thank you.
Great sharing. Thank you. Now, moving to our next segment, the evolution of generative AI models. Let's start with the topic of pushing the frontiers of AI innovation with generative AI models. Please welcome Jeff Fu, Senior Director of Product Solution Architect, Alibaba Cloud Intelligence Group.
Good afternoon. I'm very glad today have a chance to introduce our Qwen and Qwen's update. And I'm from the product solution team of Tongyi Lab. So our lab developed the Qwen model, Qwen's model, but our team responsibility is help people or the company to using our models. And so another name of our team is commercialize team. So we help our model to commercialize. Okay, so today I have 4 topics. First, I will quickly introduce our model family. As you heard these days, we released 7 new models yesterday, and we also update more than 10 models. So here we have some quick update. Later have an overall picture how our model family. So the second part will have the Qwen model update and the Qwen model update. This is our major 2 model families. And the last part, I will have some technical insight or forecast for the model development in the near futures. And because you already heard some update from our CTOs and our other teams, today I will more focus on the technical part, how the background or the backside for the model training and development. Okay. So I think you already see this picture these days. Almost every slides of the presentation will have this size of picture, but whatever our mass is in the middle of it. So we have the eyes, AI's eyes, AI's path, and AI's mass. And above it is our AI's applications. Our Tongyi Lab is working on the middle of it, including we developed the Qwen's model, Qwen's model, and also we have the model scope. It's our model as a service to provide all kinds of API and agent flow functions. We also have the hosting lots of third-party model or the industry or verticalized model for different purpose. So the middle part is our Tongyi Labs, and above it, also we have developed several applications for our different purpose. Like for the coding, we have the Lingma is for coding, Xiaomi for chatbot, and also for some legal, some is for calculator, and some also for the newsletter writings. So for our Tongyi Lab, as again, we have the mass, and we have also several selected AI applications. Okay, so move on. And this is our AI strategy for our Tongyi Lab. We have 2 parts of major strategy. One is we call the rich model supply. Another is called one open source. So for the rich model supply, we provide the full range of model size from very, very small 0.6 billion parameters, so to the very large, about 200 billion model size or parameter size. So different purpose, the model. So some is for, you will see we stored in the PC or the cell phone or the smart car. Some is on the data center. So I will introduce later. And another rich supply is we provide all kinds of comprehensive modality models, include the VLs models, math model, coding, and reasoning. So this is our, I will introduce later, we will provide all kinds of model for you. The second part is we are very stably working on the open source, because we think open source is very important for the large language model industry. So we already provide more than 300 open source models in the Hugging Face. You can download all kinds of models as mentioned above. And right now, we already have more than 600 million download for the model in the Hugging Face and other website. So that's because we really insist working on the open source. So right now we are the #1 of the download number in the market. And this is our family. I don't want to mention again. So here, it's, as I said, we have Qwen model for all kinds of multimodalities, the VLs, images, and we also have the Qwen for the text to image, text to video. I will introduce later. Okay, so These days, as I mentioned, we have at least 7 different models, so I did not go through one by one because the limit of time only give me 25 minutes. So I pick up some important model update today. So here I will, for the Qwen models update, I will introduce the Qwen 3 model, the Qwen Next, and the VL, Omni, and the Coder. These 5 major update. Okay. So first is Qwen 3. As you heard yesterday, Qwen Max we just released yesterday. This is our first model with over more than 1 trillion parameters. This is a very, very large model. And it provides lots of comprehensive capabilities. First is, as right here, our general capability is much bigger compare our previous model, and also compare the market, the benchmark like the cloud. We also better than them, and DeepSeek in all kinds of general questions like the mathematics, the coding, and also other general knowledge. So all of them you will see we are much better than previous version and get the SOTA in the industry. And also, see, because of the large of the model size, see, we have much broader knowledge coverage in these models. Okay, so this is Qwen 3 Max, the biggest release these days. And the overall Qwen 3 models we released at the end of April this year. So this model we have totally we have we have 6 dense model, 2 MOE model, and also plus 3 commercial model. The dense model and MOE model is already open sourced. The commercial model means we just provide API and not open sourced. So totally, we will have so many models. And this model, the difference compared to the previous version, we are much more training token. Totally, you have 36 trillion token to train it. And also, when it released, we already support 128 token for import. And right now, we already upgraded it to 1 million context for import. Okay, so and also this model is we support Apache 2.0. So this is very user-friendly for, we also the open source friendly for the developers. And we also support 119 language. Okay, so you can access all this model in our model studio in China and outside China. In China, we already have the one station, we call the model studio station. Globally, we have in Singapore and in Hong Kong, we have 2 sites. You can access all kinds of our models. Okay. So here is some comparison with our Qwen 2.5. So as what I said, one thing is our token is much doubled. Training token is doubled, and also our support language is 4 times more than comparison. And also the performance of view, our new model achieves the small size compared to the previous bigger models. So this is the performance comparison with the previous one. Okay. So this is our benchmark in the industry for the Qwen 3s. Okay, and 2 months ago, we also upgrade. We have a major upgrade for our Qwen 3 models. We call the version of 2507, this new version. This new version have lots of major upgrade. One of the important upgrade is we using the GSPO training method to replace the GRPO, and this is GSPO is training based on the sequence, not based on the token. So this is much stable for I/O training and also reduce the training time. We have a paper to very clearly and detailed introduce how we using GSPO for training the new model. And so right now our model, the training speed is much faster than previous one because we all based on this GSPO's policy. And also we, as I said, we also extend the context length. At the beginning, it's about 108 context input. But right now, it's already upgraded to 1 million. And we also plan to, at the end of this year, we hope we can upgrade to 2 million context. And technically longer, maybe 10 million tokens in the future. So this is our technical update for this part. And the second important model I want to introduce is Qwen Next. Qwen Next is a very important architecture for us. In the future, we will upgrade this model to the Qwen 3.5, the next generation of model. So this model is based on our two futures trend. One is we know we foresee the context length will be longer and longer. This is one trend. Another trend is total parameter is also scaling and more. So how to deal with this situation? So we provide, we working on the Qwen Next architecture of the model. So this architecture is compared to the previous version. We have the ultra higher aspect ratio. Previously, we have 16 experts in the MOE architecture. Right now, we achieve 50 experts in the models. And in these models, we have 2 layers, and 70% of is we call the gate delta net, and 25% is from the gated attention. So this delta net is good at for the long context, and also this gated attention is good at for the overall knowledge, but this takes time, and this is not complexity of n. This is complexity of the power of n. So this is much take time. And in this new Qwen 3 Next models, we combine them like 75% and 25%. So this is balanced for the new architecture. Okay, and we, as I said, in the later our new Qwen 3.5 will iterated based on this new architecture. And this also could achieve very good performance and balance between the performance and the efficiency. Like here, this is for prefill throughput, this is 10 times compared to the dense model, and also better than the previous MOE model. This also the decoding throughput is also much faster than the previous one. So overall, we believe this model will be a very good future for us. Okay. We also have some paper about this Qwen Next model. So if you are interested, you can read through it. And also from the performance of view, it's also very good compared to the previous one. And also the most important is the efficiency. The training efficiency is fast. Okay. Okay. The third part is the VL, another important model for VL. And this is we released, we call the Qwen 3 VL model. This is our new generation of model modality models. This can include, they can read from the pictures, videos. You have the vision encoding module to put them tokenize it, and also merge it with the text token and merge together, and have the decoding module to do it. And so based on this architecture, we have also some big upgrade for the Qwen 3 VL models. The size, as I said here, the size of view from small to big. We have the biggest, the Qwen 3 VL 72 billion tokens. And we also support a long context. Right now is already 1 million context. And also they have the 2D and 3D grounding capabilities I will introduce later. And also here, as I mentioned, they can understand the videos, not only the picture or images. It can also read through understand the videos. Okay. So here is some major highlight for these VR models. You can see here is it's like one thing is we call the native dynamic resolutions because based on the nature multimodality capability for the VR model, it can read the picture, do the and also videos. They put the same model, and this have also we call the deep stack module to deal with this informations. So this will be understand the picture and also videos. And also, they can see the dynamic world because normally VR is reading the pictures. But after our new architecture, we put the timing into the time step, put it into the encoding it and put it to the modules. So right now, we also can read through the video because they have the time step. And also, they can have the understanding or awareness of the 3Ds, just like the demo shows. They can see the people from different angle and also the different furniture in the room. This is also why right now the driver, the auto driver, like the Lingjun and other companies, they are using our model, train our model to using the VLA because we also provide the 3D awareness capabilities. And also, this is also very interesting functions. The VL3 model can thinking. They can thinking of the based on the image, like here, like ask what's this architectures, what's the book, and so the VL model also can understand and also can do the interactive things with the user. Okay, so this is also the VLs. And then is the Omni. Omni is also, yesterday we released the Omni 3 models, or the Qwen 3 Omni. So this is a very important, we call the end-to-end multimodality model. This is also similar as the VL. It can support all kinds of input, like here said. They can import the text, can import the video, you can import also the audio. So all the information, 3 or 4 type of the information, text, video, audio can import to here. And also they have the sync model. Sync model will extract the information and plus similar like the VL, they will extract and embed it and to the talk. Talk is the decoder models. So this encoder, the Qwen 3 Omni is like said, sync and talk models. And we also using the 20 million hours audio information to train it. So right now, it can support about 19 different language to speak and understand. Okay, I will have a demo for it. You can read this.
I took my French friend to an Italian restaurant for a meal. Could you please recommend a pasta dish for us and introduce it in French?
Okay, next I will introduce to your friend in French. Bonjour mon ami, je vais te recommander un plat. Je pense que les tagliatelles au bœuf bolognaise sont un excellent choix. C'est un plat classique de la cuisine italienne avec des pâtes larges et plates et une sauce riche au bœuf haché. C'est un plat très satisfaisant et je suis sûr que tu l'aimeras.
Presenta brevemente el contenido de este sitio web.
Esta página web es el sitio oficial del Museo Picasso de Barcelona, que presenta principalmente la historia de los 5 edificios históricos en los que se encuentra el museo y la historia de la calle Moncada.
So as this demo show, Omni is major used in the language-to-language talking, okay, and also it shows the cross-language, okay. So the last Qwen model update is Coder. We have already released this Coder module this year and get very good feedback in the globally, like the open routers, the ranking. When the Q3 Coder launched, we are ranking the number 2 in the market. Overall API calls. Okay, so also I can show a demo using the Coder to do. This is a demo based on the Coder's capability. So normally this is difficult to write as a program, make sure the ball is bouncing in this 3D situation. But right now using our co-model, Coder can write it. Okay, then I will have some quick update for the WAN models. For the WAN models, the major capability of WAN is for generate the picture and or the video based on the text or based on the image. So for us right now, the major update is we provide we call the native multi framework. So it can support the text, picture, and the audio, all kinds of things together to input together and generate the result of the language, audio, and the image. Because normally this kind of model only can generate the picture and the video, but for the WAN 2.5, we can also generate the audio. So I give some sample.
Go on, get off my property! No visitors today or any day!
Yeah, so this voice is automatically generated by the WAN models. Okay. So another example, okay. Okay, so this is also generated by image. Okay, you can see it's based on the prompt. It can generate the picture, and also this kind of complexity mind map. This also can generate. Okay, so last part is for the technical forecast. So from our view, and our Tongyi Lab have some insight for the future. We think the first thing is the context length will extended. Right now, as I mentioned, we already provide 1 million context input token. But in the future, we hope at the end of this year we can achieve 2 million or 4 million context input. And we hope in the future, next year, we can arrive maybe 10 million input and even longer. Because if we can provide the long context, so you can input more information in it, and also the module can be smarter and can do more complex tasks. So this is one thing. The second thing is the parameter of view. And as I mentioned, the Qwen 3 model, this is 1 trillion token parameters, and with the MOE architectures. And we see next year and the future, the size of view will be bigger because we have a very good MOE architectures. So the overall model will be bigger. But with the MOE architecture, we can balance the size and the efficiency. And also the data of view. Right now, we training with 36 trillion token to train our new model. And next we will continue increasing our token training data. So we hope we can achieve 100 trillion tokens in the future. And also the IO is very, very important, as you see all kinds of paper right now. But right now, we only have 5% of computing time is used for IO training. But we think in the future, with the high quality of IO data, we hope we can achieve 50% of our training is based on the IO knowledges. Okay. So the last part is we have some important information website. Like if you want to try our latest model, you can here. And all our new latest paper model will released here. And also have our model scope. We also will release our latest open source model in the model scope. Okay, that's all for my today's sharing. Thanks for listening.
Thank you, Jeff. Focusing on specific market applications, we now have Edwin Lee, CTO of Flux, to discuss Qwen models applications in the Japan market.
Okay, so thanks for the opportunity to stand here. And basically, I'm going to talk about Qwen models application and also something about the AI market in Japan. It's kind of a niche topic, but I think lots of you have already heard about lots of technological stuff right now. So I'll doing something not so technological. But then after my presentation, we'll have an exciting announcement with Tongyi Lab and also Alibaba Cloud. So let me just briefly introduce myself. I'm a CTO of Flux, and also I'm a researcher in Matsuo Lab in University of Tokyo. Since I don't have that much of time, let's just skip this. And so today I'll talk about 3 things for the Japanese AI market and Qwen. First, I'll give a brief overview about the Japanese AI market. And then I'll introduce some interesting use cases like how Qwen is actually used in Japan. And the last thing, I'll try to talk about some of the AI opportunities in Japan, especially. So the first part, it's kind of simple. Like Japan is it's definitely not large enough compared to China or America, but still it's a good mid-sized market for AI, and it's growing steadily. And also for 3 different branches of the market, let's talk about enterprise adoption and government support and also academic stuff. So for the enterprise, actually, I used to do another panel talk yesterday, and I talk about the kind of Japanese enterprises lags behind in digital transformation stuff. So basically, they are pretty behind for digital usage and digital transformation, and as we call in Japan, DX. But right now, because lots of the people in the engineering field have become older and older in Japan, so there's a huge need for AI usage. And that's what we call 2025 digital cliff. So it's actually happening. So there's a huge push in Japan for enterprises to adopt AI use cases, which is actually unheard in the few decades before. And also there's another thing which is actually related to the government, is called the AI Promotion Act. It's also interesting because I don't know what you imagine about lawmaking in Japan, but actually Japanese government really embraces the usage of AI. And they're trying to make, Japan is definitely not strong compared to China and America in AI development, but still they're trying to make their lawmaking environment really good for AI. So that's the AI Promotion Act. It's basically one of the laws directed by my professor. It's Matsuo Sensei, we call it, Matsuo Professor. And also, talk more about job government support. We have this program. It's actually a GPU program from the government called GENIAC. It's that they will cover over 90% of your GPU usage. So they will just, let startups and AI companies build their own fine-tuned models. Because, in Japan, you don't have enough people and GPU to build a model from ground up. And also, there's an organization called LLM.jp, which is led by the National Institute of Informatics. And it's a national institute on AI and digital research. And they have this branch called LLM.jp, and it's releasing one of the most authoritative AI benchmarks in Japanese. And also, I talk about lawmaking, and also to talk more about the academic part is actually, Matsuo Lab is definitely one of the center of innovation of AI in Japan. And I have to say, most of the AI startups, so-called AI startups, are related with Matsuo Lab. So we have a really unique atmosphere in our, lab. And basically, our professor is saying, if you want to do AI, you have to start your own company. Just don't go to any large enterprises in Japan. So it's kind of interesting. So most of our students are starting our own company right now. And also, we see from Japan focusing on AI investment, AI applications recently, so it's pretty interesting. Before I talk more about how Qwen is used in Japan, let me just talk a little bit about how Japanese social acknowledgments about Qwen is currently is now. So you might heard about this Nikkei. Is one of the most famous business and economics newspaper in Japan, and I actually asked my friends from Alibaba Cloud Japan. They said this is not a sponsored article. So yeah, but this is not a sponsored article. It's an article that's written by the newspaper themselves. And they basically said they have their own model score benchmark. And they said it's the Qwen 2.5 Max is ranked 6. It's basically, I think it's this May. And so I think like we can do better right now, maybe. And then basically what they're saying is the Qwen from Alibaba is becoming the foundation for Japanese AI. Because just like I said, I mean like for Japanese companies, it's really hard for them to build model from scratch. So they have to use some open source model as their foundation. And I think right now the takeaway, the go-to option for that is Qwen. And based on that, let me just introduce some more cases. The first one is called, a listed company, an AR startup called Abeja. It's actually pretty famous in Japan. And they claim they built a reasoning model that surpassed the capability of GPT-4o. But it's actually based on QWQ 32B. And this project is actually pretty interesting. If you look at this project is actually funded by GENIAC, the government funding I mentioned. So you can see there are lots of government-funded fine-tuning projects based on Qwen starting to happen in Japan right now. And also there's another famous startup called ELIZA, is recently half acquired by a famous telecommunication company called KDDI in Japan. And they are actually a strong natural language processing company, used to be. But then after the emergence of a large language model, they start to transfer their roles from natural language processing to large language model. And now recently they released a reasoning model based on Qwen 2.5 Instructor. So these are some nice use cases for famous AI startups utilizing Qwen in Japan. And not only famous startups are using this, I'll show more cases about industry models. So this is actually an interesting one. I don't know whether some of you have heard of Preferred Networks. It's actually the largest startup in Japan. It's the largest unicorn in Japan based on valuation. And also they have this famous AI framework called Chainer. So back in the days, before PyTorch, we used to use Chainer to program neural networks. So Chainer is actually released by Preferred Networks. And they recently have built a medical large language model for Japanese medical data based on Qwen 2.5 billion. So this is a nice showcase of the most famous AI startup adopting Qwen to use them for industrial use cases. And also there's a famous startup focusing on autonomous driving called Turing. And I think this startup is actually pretty much related with Toyota and other car makers in Japan. And they're actually using the vision language model. They have released their vision language model, and it's actually based on Qwen 2.5. So I read their release, and they said they compared the models with Qwen and other options, and they found Qwen is the most efficient and most accurate one, so they used Qwen. So these are some really nice showcases of how Qwen is actually pretty silently adopted by the Japanese market right now. And I'll talk more about the Japanese AI opportunity a little bit. So there are different aspects when you think about AI opportunity as a country in Japan. And one of the most interesting thing is because in Japan, there's a strange system called lifetime employment. Basically, there's not enough engineers inside the company. So there's a data set, only 70% of the engineers in the market are in-house engineers. Most of the engineers are outsourced. So most of 70% of the engineers are from an outside vendor, which is actually really unique only in Japan. And also because of that, there's not enough in-house experts. So this is definitely a problem, but that still poses a new chance for AI startups or AI companies to build AI-driven engineers and AI experts for large enterprises in Japan. Because there are, they have too many outsourcing vendors in Japan, and they are charging really a lot for these engineers. And also there's another thing, especially on generative AI. We are an AI solution provider and also an AI consulting firm in Japan. So I talk with lots of huge enterprises, CIOs, CDOs, and they all said they're really concerned about data leakage and cost and customizability. And also they don't have enough engineers, so they don't have the engineer resource to do the maintenance. And I think the interesting thing is, if you look at data leakage and cost and customizability, most of the cases could be solved by using an open weight or open source model like Qwen. So I think that's the reason why Qwen really fits the Japanese market right now, especially for the enterprise. And because they don't have enough engineering source, so they have to rely on some company like us to do the implementation and consulting and the planning part. And so that's the reason why I think like in Japan in the future, we have a huge chance to collaborate with Qwen and to make Qwen models definitely into more use cases for large enterprises in Japan. And that's basically my presentation here. And here's the exciting announcement from us with Alibaba Tongyi Lab.
Now, let's have the launch ceremony of Flux Japanese Qwen. Please welcome Dr. Ye Jieping, Vice President of Engineering, Head of Data to Intelligence Lab, Alibaba Cloud Intelligence Group to the stage. Please put your hands on the screen. That was exciting. Let's now explore our final segment, leveraging models to create innovation applications. To show us how to build your own generative AI applications easily, please welcome Wen Yuan, Head of the Engineering Team, Tongyi Lab, Engineering Head of Alibaba Cloud Model Studio.
Thank you. Thank you for the introduction. My name is Lingjun Yu, and I'm from Tongyi Lab. I'm the head of the engineering team of Tongyi Lab. Also, I'm also the engineering head of the Alibaba Cloud Model Studio product. Because I don't know, because maybe my original slide was hugely complicated with Jess' presentation. I wanted to go over like all the model offerings on Alibaba Cloud Model Studio and show you some innovative ways to leverage our models. But I think, his presentation basically said it all the models, all the recent developments. So I will cut short my presentation. I will focus on some product feature of the Alibaba Model Studio, Cloud Model Studio instead. And maybe if you have any more questions, we can maybe talk about it offline after my talk. Basically, Alibaba Model Studio is a model as a service platform for Tongyi models, including Qwen and Qwen models. From the history of Tongyi models dates back maybe 8 years ago when we start to do pre-training or for like bird, talisman, etc. Gradually, we try to train more and more models, and since like ChatGPT and we also double down on our investments on training new models. For example, Qwen got we have lots of model release in the past 2 years, and one also we open source last year, and other we have other models. For example, the human AI is for animate a picture, and since last year we released Model Studio in China and also globally, and since then we offer more and more Tongyi models as a service on Alibaba Cloud Model Studio. It's for now the Model Studio. I'm not sure whether you have used it, because I think Tongyi's models gradually get some traction overseas, and many developers reached how to use Tongyi models online. Of course, lots of models are open source, and if you open OpenRouter, you can see lots of vendors providing the inference service with Tongyi models, especially Qwen models there. And but there are still a few problems with that, even from our observation. Firstly, such inference may not be as of the same quality of the original inference. We tested with against some benchmarks, may not get the same score. I don't know why. Maybe they use some over quantified version, or there's something wrong with their inference code. So providing a reference inference API service, I think, is crucial for our models, for our users overseas to use the models. They know this service can be reliable. This service can be of the same quality of inference quality of the original model is supposed to be. Yeah, and also I think our inference infrastructure, our in-house infrastructure, we are really proud of, and we built with Alibaba's infrastructure team, and we can offer a superior performance and efficiency, and also that comes with enhanced data security and compliance for etc. as a cloud provider quality of service and some enterprise level assurance. Also, it's very optimized for cost efficiency. Our model, especially some closed source models, I think it's much cheaper than OpenAI, Anthropic, etc. And I think it's it's a bargain, I think. And it offered a wide selection of models, and you can experience model online, and you can monitor the models, and it offers all kinds of Qwen 3 and 1 models. You can use it in API. Oh, sorry. Also, I think using Model Studio, there's a diverse pricing options for model services to meet different business needs. Of course, it can offer the pay per token models that you can it build based on the usage of each request, and based on the input and output tokens. And also there's a new, I think not new, but a standard, the PTUs, the provision throughput unit, it's much more suited for production grade workloads. that you can have much more predictable traffic volumes with predictable SLOs for the like latency, TTFT, or intertoken latency, TPOT. And the billing is charged based on the PTU usage duration and it support foundation fine-tune models. That's a plus. You can fine-tune a model and serve it based on the PTU option. And also, if you have lots of data to be processed by model, we also offer the batch inference, and that's suited for large-scale data and offline asynchronous processing. I think it's typically built half price of the our listing price of each model. Also, I think we have a huge offering, and I think Qiang had just, Jie has already showed the new models of Qwen and Qwen. Besides that, we also have like embedding models and machine translation models, live translation models, and character role-playing models, etc. So basically, the huge model zoo of Tongyi Lab. So you can try to play with it, use just API. It's covered from the real-time interactive models like via WebSocket or WebRTC, or just HTTP API call using like OpenAI compatible protocol, or you can use batch inference to deal with lots of data. So the advantage of Model Studio, like it's provided a superior performance, and I hope it fits the business better, and it provides reliable data security, and it provides cost-efficient AI solutions. Currently, we offer localized inference service based in mainland China and the Beijing region. Also, we offer API service in Hong Kong. And this month, we all opened our Hong Kong site. It's, you can use the local GPU for the inference service, and I think more to come. Hopefully, maybe Japan. I don't know, maybe other area. So I think we have more sites planned for compliance and suit local needs. Okay, thank you. This is my quick talk. If you have any questions, we can talk about it later offline. Thank you.
Thank you. Next, to explore a new paradigm of agentic coding, let's welcome Eric John, Head of Product, Coder.
Hello, everyone. This is Eric. I'm Head of Product, Coder. So, last week, Anthropic and OpenAI released the two reports. The consensus is about the large language model is from the knowledge retrieval to the action taking. So it's mostly focused on the task automation. So this signals is a human-AI collaboration is from the knowledge retrieval to the task automation. So it means we do not expect the AI to inform us what, and we expect to AI act for us. So I would like to do a quick survey. So if you are a programmer or have been a programmer, please raise your hand. Okay, thank you. So I write source code more than 20 years. So previously, so I used the DOS, disk operation system, right? So let's just have the test box. So we just type in. So later, so we use the basic language. It's also a symbolic language. But right now, so my daughter is around 15 years old. He can write the source code using the natural language. So this is the AI bring us. So that so rapid advance of the technology is preparing the swift progress in the AI coding area. So in the earlier release months, so Qwen released the Qwen 3 Max. So we can expect it rate the programming scope expanding from the chat and the compression to the task and the feature implementation. So it means that later so will impact the whole software development lifecycle. So from my perspective view, so I divide the AI coding in 3 stages. The first stage is around 2023. So we call it the collaborator part. So we know so GitHub Copilot and another Copilot, AI Copilot tools. People just to follow the manual to trigger, and the AI will suggest some source code for you. Then later, so in the 2024 and in this year, so we talk about is the agentic coding area. So especially, so Cursor introduced the composer features. It means the AI coding tools can suggest the source code for the whole project. It can edit the whole project and modifies. So right now, so the productivity maybe will improve the 15%. But in this year, so we talk about how to delegate the coding task to agent. So it means so people just write the requirement and do the requirement refinement, and then delegate the tasks to AI. The AI will autonomous coding for us. For example, so if you are close your laptop, if you are send some task to the AI and close the laptop, and tomorrow morning, so you can go to your office and open your laptop to check the AI's code result. So it means so the autonomous programming slice is from left to right. So this person is right the memes, right? Okay, so is Frederick Brooks. Frederick Brooks is indicate the software, real software development challenge is still there. It's about the complexity, conformity, changeability, and invisibility. As we know, so today there is vibe coding is quite popular. Every day the social media has a lot of wall project. For example, so maybe one little girl write a real fancy project for us. So, but this significant software challenges are still there. So, for example, so there is some tacit knowledge in our organizations. So it means so we cannot understand the organization's invisible knowledge well, so that we cannot cooperate well. So the software deliver will be hard and harder. And then another challenge is about so our software engineer. They have to spend a lot of considerable time for the coding, not than for the requirement refining, right? But as we know, so it will lead a problem that is garbage in and garbage out. If we can write the specification well, so we can write the source code well, but we use the most time for the coding part, but we use less time for the specification, right? Okay. So in this area, so in AI area, so maybe the AI can help us for the code writing. So people should most focus on the requirement refining. Okay, so that code is built for real software development. Some philosophy behind our product is first is knowledge visibility. So we can use the AI to translate the symbolic language to the natural language, that people can understand the lexic source code well, and so that is can offload the cognitive burdens to understand the lexic source code. And another part is about the specification-driven development. It's not a purpose, it's just a way. The purpose is dedicate the coding task to the AI. So if you would like to delegate the task to AI, so you have to write the specification well. But AI can help us to write the specification better. And another part is so AI write the source code well. AI should understand the real world well, right? Okay. Bad context read bad code. So we spend a lot of time is about the enhanced context engineering. So from the prompt engineering to the enhanced engineering, so that AI can understand the code base, can understand your organization's documentations, so that the AI can write the source code according your preference, right? Okay. So that the first feature is about RepWiki. So the RepWikis can make the knowledge visibility, so that AI can translate the source code into structured documentations. It's about the whole overview, architectures, some modules implementations, and also some UML chat. So if some persons hand over a lexic source code to you, so you can easily understand what it is. Okay. So the second feature is about the programming through conversation. It's quite normal in kind of copilot tools, right? So as persons can chat with the AI, so the AI can break down the tasks and do some iterative chatting with the AI, so the feature can be incremented step by steps. So we call it okay. We only 3 minutes. Oh, let me go fast. Okay, so this is just for the pair programming with AI, but there's a new moral laws of AI agent. It means so the task length will be double every 7 months. So it means AI can do more works, and not just only chat for the iteration chat, do some programming works. So we think that in the real-time pair programming, with just programming via the conversation, we call it a real-time pair programming. So developer requests to agent, and the agent can help you to write the source code in real time. So, but as I mentioned before, if you would like to delegate the task to AI, so it means developer can send some tasks to AI, and there's a lot of agent that can be executed on the cloud, right? So tomorrow, you can open your laptop to check result. We call it task delegation. Okay. So we offer a quest mode. The quest mode is for the delegation task to agent. First, the person's write the specification, can understand the requirement well, and then the AI can autonomous coding based on your specification. Okay, so the first step is write the specification, then the AI execute that. No news is good news. And then later, it will verify the result, tell you a trusted result to you. Okay, so there is still have challenges, right? If you use the agent, pair work with the agent, or you dedicate the tasks, so we have to spend the temporal or spatial boundary of AI coding, with your coding everywhere and coding every time, right? So we offer the asynchronous autonomous agent and remote sandbox, and also to expand the interactive actions for the AI. So we offer such like illustrated. So we have the remote sandbox on the cloud, and then later, for the IDE or terminal can connect it with the sandbox. The agent can run here, and from the Git repository can connect it with the sandbox. And for the IAM tools, can connect it to the sandbox as well. So the agent can run in anywhere, right? Okay. But another challenge is about AI coding is for the quality, performance, and cost, right? We call it the iron triangle, right? So we have to get quality and fast performance and the chip cost. So these days, if your accuracy of the agent is 90%, after 20 steps, the accuracy will be 0, right? So because the task delegation is a long task, it's a lot of steps. So we use the enhanced reflection and iteration and a lot of verification tools integrated into the agents. It can improve the accuracy of each steps. Then to improve the task completions, right? Okay. Another problem is about the cost. So multi-step task will cause the context window goes bigger and bigger, right? It's like a snowball. So we will use the enhanced tools, and we will choose the optimized models, and we will use the sub-agent architectures to resolve this problem. So that we get some result. For example, currently you can support for massive project with up to 100,000 project files. And so that for the performance, these days we increase the 13.22%, right? And for the task completions, we can use the same resource consumptions, but we can do more works fast. Okay. So the last question is about the future of agentic coding. So what can we expect it, and how should prepare, right? Okay. So we think that later, the programming language from the symbolic language to the natural language. This is our thinking. So most of project coding will be taken by an AI agent. So, but according to the Java's products, so the number of developers won't be decreased because there will be more features, more requirements come to us. And for the developer should know how to design the source code, how to do the architecture. It's such like the calculator is changed a lot, but the content still right? Okay. And another one is the minimum capability. So for developer will generally increase. So this is our thinking. So, but I would like to do some prediction. Even though the prediction is quite dangerous, right? So, but the first prediction is later will be more than 80% of features will be done by AI, autonomous. Is come true because we use coder, right coder. The second is remote agent will be the mainstream. For example, as I know, cursor, argument, and another tool, and the codex also implement the remote sandbox as well. And another one is the coding agents become truly ubiquitous. So it can be everywhere, like I mentioned before. So you can IDE connect to the remote agent, terminal, GitHub, Git repository, or some IAM tools, some web-based tools can combine together. So it will be agentic coding platform will be a fundamental platform, all right? So every end will be seamlessly connected with the platform as well. So this is my presentation here. So it's quite quick. If you have some questions, maybe we can talk offline. Okay, thank you.
Thank you. Our final speaker for today is Fu Cheng, CPO of Lingjun, who will discuss why we need a framework-agnostic agent marketplace. Welcome.
Hello, everyone. Thank you for joining me today. I'm Cheng Fu. I'm the Chief Product Officer of Lingjun. This is the last session of today, and I believe most of you are hungry, so I'll just keep this short and effective. So in the next 10 minutes, I'll cover three things. First, is that why being agnostic is actually matters. And the second is how Neuron is implementing a framework and the model agnostic agent marketplace. And the third is the future of agent ecosystem. Okay, so let's dive into the problem. We are now living in an area of incredible diversity in AI industry. We have many new models, new architecture, new framework pops up every few months, each bringing new capabilities. We have Cloud 4 model families that are expensive but best at coding. We have Qwen 3 model families that is open source and cost effective. We have GPT-5 model families that is cost effective and better at writing and translating. And we have a bunch of agent development frameworks that performs well in their verticals. Imagine if you are a agent marketplace and you are bound to only one of these models or only one of these frameworks, what you will get. On the surface, it would be simple and easy to adopt for your users because you have only one model or one framework. But if you think back, you will have many downsides. Let me give you some examples. So now you can create custom experience in ChatGPT using GPTs, which is a very powerful capabilities. But GPTs are bound to GPT models only. You cannot use other models in GPTs. So if you are a developer that create a coding apps in GPTs, and now Cloud 4 is the best coding model, and the developers have no loyalty to the models, so what you are facing now is your users will leave because you don't have the most powerful model for coding. They will leave your GPTs apps. Yeah, and as a second example, if you are tied to one of those workflow frameworks, we can think of many names. You can only create chatbot agents or content generation agents. Now, if you want to build a, let's say, design agent, freeform design agent on web-based canvas, on top of that workflow frameworks, it would be very hard. Yeah. So a marketplace should be very flexible. If you are not flexible enough, you will lose your developers and your end users. So from the perspective of developers and end users, the optimal strategy for a marketplace is you should minimize the constraint. You should let your developers to decide which model or which framework are best for your agent. And you should let your users to decide which is the best agent to solve your problem. So that's the core value of being agnostic. Okay, so here comes Neuron. Okay, as you saw, Neuron is a platform developed to remove the restrictions on models and agent development frameworks. You can upload chatbots agents, workflow-centered agents, conversational agents, browser use agents, or even computer use agents. And by enabling this, our Creator Studio can make the developers be able to upload different agent types from developers from different agent frameworks. And we are working hard on expanding those types supported by this platform. So by enabling cross-model, cross-framework agents, we are helping prevent one company from monopolizing the full agent stack. I think the most important thing for this agent ecosystem is to let many players participate in this race and win on the basis of innovation and competition. We don't want to live in a future that one company rules them all. Yeah. So what does this lead to the future of agent ecosystem or agent economy? We believe that there will be many more participants in agent economy, and the agent economy will evolve into a whole agent ecosystem. We will have real human users as the user of the agents. We will have AI agents as the user of different agents. We will have devices and other machines as the user of different agents. And what we can offer here is we have a one and consistent endpoints for a whole world of different agents. And we are going to focus on not on the models or the frameworks because we are agnostic, but we will focus on different protocols. This industry is heavily invested on open protocols. We already have many protocols in the agent economy. The first is API. I think many of you have already know, and the protocol for agent to talk to tools, which is MCP protocol. The protocol for agents to talk to agents, which is A2A protocol developed by Google, and agent to code editor protocol, which is developed by open source community. And AGUI protocol is a protocol that helps agent talks to the real human users on the web page. And another is a new protocol that just launched last month, which is agent payment protocol called AP2, developed by Google. We believe that we stick to those open and widely accepted protocols. We don't want to invent yet another closed protocols on our own. We just stick to those protocols, and any agent that complies with those protocols can be listed on our platform and interact with other agents and monetize on our platform. So that's the future of the agent economy. Yeah, and so if you want to find more information on our platform, please follow our official account. I'll leave this page for a couple of seconds. Okay, that's all of my presentation. Thank you.
Thank you to all our distinguished speakers for their incredible insights today. And thank you, our audience, for joining the International AI Technology and Product Forum. We hope you leave inspired by the future of AI. Enjoy the rest of Apsara conference.